Hello students, in today's lecture I will discuss about midpoint circle algorithm. We know that the equation of circle is x square plus y square is equals to r square, and r is the radius of the circle. And by using this equation we can draw a circle by plotting the value of x with the corresponding value of y by reformulating this equation as y is equals to plus or minus under root of r square minus x square. Now circle is having a property that is called as octant symmetry, and octant symmetry is also known as eight-way symmetry. That means the circle is having 8 parts and we have to approximate only one part, and rest of the 7 part can be drawn by the concept of octant symmetry. So what is happening in this lecture, we will discuss about midpoint circle algorithm, and we will only plot the 1/8 portion of the circle, and the portion is in the first quadrant. That means we will plot from y-axis, that is from this point, which is starting as 0 comma r, where 0 is the value of x and r is the value of y, and we will continue to plot until and unless the value of x becomes more than y or the value of x becomes equals to y. So you can see from this figure we will only plot this part, and the remaining part can be obtained by using the concept of symmetry. Now, as we have already seen in the last lecture, and the last lecture is all about Bressenham's line drawing algorithm, and this midpoint circle algorithm is also based on the same concept, and this algorithm is also designed by Bressenham. Similarly, to the case with lines, there is an incremental algorithm for drawing circles, and this algorithm is called as midpoint circle algorithm. Why the name of this algorithm is midpoint, that we will discuss in the coming slides. In the midpoint circle algorithm, we use 8-way symmetry. So only ever calculate the points for the top right 8 of a circle, and then use symmetry to get the rest of the points. So you can see from the figure, we will start from this point, and this point is denoted as xk comma yk. And one thing we have to remember in midpoint circle algorithm, that we will start drawing a circle from the origin. That means we are assuming that the center of the circle is at the origin, and whenever center of the circle is at the origin, you can think this point as 0 comma r, where the value of xk is 0 and the value of yk is r, and r is basically what? It is the radius of the circle. Now what we are doing, we are approximating the value of y. So from xk we are moving to xk plus 1. Now at xk plus 1 we have to decide whether we should activate this pixel which is at xk plus 1 comma yk, or we should activate the pixel which is at xk plus 1 comma yk minus 1. So you can see that the values of x are increasing while the values of y are decreasing. Assume that we have just plotted point xk comma yk. The next point is a choice between xk plus 1 comma yk and xk plus 1 comma yk minus 1. So what we have to do, we have to decide, or we have to choose which point we have to activate, xk plus 1 comma yk or xk plus 1 comma yk minus 1. We would like to choose the point that is nearest to the actual circle, and obviously we are going to choose a point which is nearer to the circumference of the circle. So the question here is, how do we make this choice? So the answer is the name of the algorithm, and the name is the midpoint. So we have to choose a midpoint. Now again, as we know that the equation of the circle can be represented as a function f circle x comma y is equals to x square plus y square minus r square. And as we know from the property of the circle, if we choose any point which is inside the circle, and if we are substituting the value of that point in this equation, then obviously the value of f circle is less than 0. While if we choose any point which is on the circumference of the circle, then the value of function fx comma y is 0. And if any point is outside the circle, and if we are substituting the value of that point in the circle equation, then obviously the function will has the value more than 0. So this is the property that we all are familiar, and by making use of this property we will move forward. By evaluating this function at the midpoint between the candidate pixels, we can make our decision. So obviously this function will help us as a decision parameter, and it will help us to choose which pixel we have to activate. Now assuming we have just plotted the point at xk comma yk, so we are starting from xk comma yk, and we are assuming that this pixel we have already activated. Now the next pixel is either xk plus 1 comma yk or xk plus 1 comma yk minus 1. Okay, so now what is happening, we are choosing a midpoint. So you can see from the figure here, we are choosing a midpoint between these two pixels. Then obviously you can see that whenever you are choosing any midpoint between these two pixels, the value of x is obviously it is always remains same, it is xk plus 1. And now what about the y value? The y value will be yk minus 1 by 2, because it is the point is between yk and yk minus 1. And obviously if a point is between yk and yk minus 1, then the midpoint will be at yk minus 1 by 2. So you can see here we are choosing the midpoint, and we know that the coordinates of midpoint is xk plus 1 comma yk minus 1 by 2, and we are substituting the value of x as xk plus 1 and y as yk minus half in the function. And what is the function? Function is x square plus y square minus r square, and in that case we will get the pixel parameter at kth position, which we are representing as pk. Now this parameter will help us to make the decision. If the value of pk is less than 0, the midpoint is inside the circle and the pixel yk is closer to the circle. That means if the value of pk is less than 0, then obviously we will activate the pixel which is at xk plus 1 comma yk, while in the other case we will activate the pixel which is at xk plus 1 comma yk minus 1. Now we are doing the next approximation, and the next approximation can be done by incrementing the value of k as k plus 1. So you can see that the point at x, the value of x coordinate of the point will be xk plus 1 plus 1, and the value of y will be yk plus 1 minus half. and again we are substituting these values in the function, then we will get pk plus 1 is equals to pk plus twice of xk plus 1 plus yk plus 1 square minus yk square minus yk plus 1 minus yk plus 1. So these all things we have already seen in the Bresenham's line drawing algorithm. The concept is very similar. Now as we know that the initial pixel parameter is at k is equals to 0, and we know that the first point will be, so you can see that if you are substituting the value of k as 0 here, the value of xk will be, you can see it will be 1 plus r minus half square minus r square, and we will get 5 upon 4 minus r. And we know that the first point is what? The first point is on the circumference and it is along the y-axis, and we know that the value of x will be 0 and the value of y will be r. So you can see from this, if you are substituting the value of x as 0 and the value of yk as r, and obviously you will able to get this equation. So from all these things we have seen that if the value of pixel parameter pk is less than 0, the next decision parameter will be given as pk plus 1 is equals to pk plus twice of xk plus 1 plus 1. While if the value of pk is greater than 0, then the pixel parameter will be pk plus 1 is equals to pk plus twice of xk plus 1 plus 1 minus twice of yk plus 1. So here we can summarize the midpoint circle algorithm as assuming that r is the radius of the circle and center of the circle is at xc comma yc, and we are assuming that initially whenever we are drawing the circle we are assuming that the center is at the origin, and we know that the first point which is x0 comma y0, its value is 0 comma r, and we have already seen that in the very first step we will calculate the initial pixel parameter, and the value of initial pixel parameter is 5 upon 4 minus r. And if you are doing the integer calculation, you can assume the value of 5 upon 4 as 1, so it becomes p0 is equals to 1 minus r. Now you have to check the value of p0 whether it is less than 0 or it is greater than 0. If the value is coming as less than 0, then we will increment the value of x, but we will not change the value of y, and the pixel parameter will be given as pk plus 1 is equals to pk plus twice of k plus 1 plus 1. While in the other case what we are doing, we will increment the value of x but we will decrement the value of y, and in this case the next pixel parameter is defined as pk plus 1 is equals to pk plus twice of xk plus 1 plus 1 minus twice of yk plus 1. And we know that if we are getting 1 point, then rest 7 points we can calculate by using the concept of symmetry. Determine symmetry points in the other 7 octants. Now the circle which we are drawing is at origin. We have to shift the circle at the position xc comma yc. For that what we have to do, we have to add the value of xc in x value, and we have to add the value of yc in y value, and we will continue this process until and unless the value of x becomes either greater than or is equals to y. So we can see that 8-way symmetry reduces the work in drawing a circle, because we are calculating 1 point and rest of the 7 points we are calculating by using the concept of symmetry. Now moving in unit steps along the x-axis, at each point along the circle edge we need to choose between two possible y coordinates, and this we have already seen. And what we are doing, we are simply incrementing the value of x, and about the y value, either we are not changing the y value or we are decrementing the y value. So here is a numerical of circle, and you have to draw a circle whose center is at 0, 0 and the radius of the circle is 10. Okay, So the value of x0, y0 is 0, 0, and the radius of the circle is 10. We know that the first point is having the coordinate 0, r, so the first point is 0, 10. We will start from the initial pixel parameter, and we know that the initial pixel parameter value is p0 is equals to 5 upon 4 minus r, and we are assuming the value of 5 upon 4 as 1 because all the calculations that we are doing in Brassenham's algorithms, they all calculations are of integer. So the value of p0 becomes 1 minus r, so we will get the value of p0 as minus 9. And we know that if the value of p0 is less than 0, then obviously we will in that case we will increment the value of x, but we will not change the value of y. X value will be incremented from 0 to 1, but the value of y, which was previously it was 10, and again it will remain the same, that is 10, and the next pixel parameter is minus 6, and again in the same we have to increment the value of x, and we do not have to change the value of y. And as we know that the circle that we are drawing is at the origin initially, and if we want to shift the circle at the center xc comma yc, then we have to add the value of xc in x and the value of yc in y, and we have to repeat this process until the value of x becomes greater than equals to y. So you can see that we started from 0, 10, pixel parameter is coming negative, we are incrementing the values of x. In each case we are incrementing the value of x. About the y value, either we are not changing the y value or we are decrementing the value of y. In negative pixel parameter we are not changing the value of y, while in positive pixel parameter we are decrementing the value of y. So you can see that these are the points which all belongs to the first octant, and by using the concept of symmetry we can calculate the rest of the points. For example, if we have calculated the first point as 1, 10, the other point in the second quadrant will be minus 1, 10, the point in the third quadrant will be minus 1, minus 10, and the point in the fourth quadrant will be 1, minus 10. So by using the concept of symmetry we can calculate all the points. Thank you.